This is the second part of the first experiment. That is the third task, that is calculation of convolution between two discrete time signals. What is meant by convolution? Okay, given two signals f of n and g of n, convolution between two signal for nth instant is given by summation of k is equal to 0 to n plus l minus 1 f of k g of n minus k. Even we can write like this, that is f of n minus k g of k. This is the convolution for instant n. Okay. So given two signals, okay, or given two array, okay, f is going to be an array and g is going to be an array. Our objective is to find the output array in which n will take the value 0, 1, 2, 3 and so on till n plus l minus 1. So that means whatever we have here is valid for only one given value of n. So in order to get the entire array output, we need to iterate this formula for n plus l minus 1 number of times. Let us see the logic to evaluate this program. Okay, I am writing the core part, excluding those io.h, printf, scanf, etc. in C program. Okay, how will we evaluate it? For n is equal to 0, n is less than n plus l minus 1. Okay, we need to put plus 1 here as per the limitations of LabVIEW. So let us remove minus 1 plus 1 will cancel, so we can remove this minus 1. N is less than n plus l, n plus plus. So this is the major for loop. For y of n. Okay. That means this for loop will iterate for different values of n in output array y. Okay. Now within this for loop we will evaluate the expression for convolution. That is y of n is equal to like this. For k is equal to 0, k less than n plus l, k plus plus, and here we will have y of n is equal to y of n plus, why I am putting y of n equal to y of n plus, we have evaluated summations earlier. Okay, how did we evaluate it? Initially we will put sum equal to 0, then sum equal to sum plus, then whatever we need to calculate. In the same way, y of n is equal to y of n plus f of k into g of n minus k. Or you can even put f of n minus k into g of k. That is also possible. Okay. During the evaluation, sometimes for low values of n, it is possible to get values like y of minus 1, or it is possible to get or index values like f of minus 1, that is with negative index. And LabVIEW, if it has negative index, all negative index will be taken as 0. So programming wise it is not at all a problem. let us try to implement this logic in LabVIEW. Let me create a new LabVIEW VI. First, let us create a array for f of k. So in front panel, array, choose an array. It is just an array template. Within that, choose a numeric control and put it within the array. Let the signal be f of n. Okay, expand the array so that it can hold 4 to 5 items. Okay, copy it, paste it somewhere. This array is g of n. Next, we need to display the output. So for that, we'll create an numeric indicator array under numeric indicator and expand it as per the length. Okay. In the program, I forgot to tell this. N is length of f of n and L is length of g of n. That is length of those signals or length of those arrays. Okay. How to calculate the array length? It is directly available. Right click, under programming in array palette there is an option called array size. Select it. If you pass an array into it, it will give the length of the array or size of the array. Copy it once again. Okay. And if we add these two things, then it will give the total length of the output signal. Next, we require for loop. Okay, this for loop is to indicate the variation in n for y of n. Okay. And for each y of n, we need to evaluate a summation. For that, we require another for loop. Okay. The loop count is actually same for both the for loop. We will interconnect them. And in the inner for loop, we need to evaluate summation. So create a shift register and give the output of summer to it. And the initial value of y of n, it is going to be 0 irrespective of n. And our logic is y of n is equal to y of n plus f of k into g of n minus k. Let us take f of k here. If you bring a variable or array into for loop, by default it will index. This is called auto indexing. You just right click it and disable indexing, because we do not require indexing here. In the inner loop only we require indexing. Okay, just to check this program, that is in the inner for loop only we require the f of k, g of n minus k, etc. So therefore by default auto indexing will be there. Right click and remove indexing. Okay, in inner loop we require indexing for one signal. Okay, and for other signal we require g of n minus k. Okay, that means we require different index, not as per our loop iteration. So disable indexing in both the loops. And in order to index an element in an array, under array there is an option called index array. You choose it. Okay, g of n minus k. So we give the signal g, and this for loop I is nothing but n, and inner for loop iterating variable is k. So we require g of n minus k. G of n minus k. Okay. Now what we need to do, that is f of k into g of n minus k. F of k into g of n minus k. Okay. Now as per our logic, y of n is equal to y of n plus f of k into g of n minus k. That's all. Our calculation is completed. And let me connect the indicator to the output of the bigger loop. Create indicator. Okay, I think there is already g of n there, that we will connect. Let us rename it as g of n. That's all. Our program is over. Yeah, let us run this program. So for that we give some test signal. Let us give the signal f of n is equal to 1, 0, 1. Okay. Let it be some kind of an unit step sequence of length 4. Yeah, it is 1, 1, 1, 1. And g of n, it is exponentially decaying kind of signal to 1.0, 0.5, 0.25, 0.125, 0. Okay, this value we will enter there, and let us check the response of the system. Let's run the program. Is 1. Second value is also 1, 1, 1. And g of n, it is 2, 1, 0.5, 0.25, 0.125, it is 0. Okay. So this is the response of the system. Is it correct? Let us check it. This is n minus k, f of k into g of n minus k. I think this should be correct. So let us check the result of convolution. I am using a free online octave which is similar to MATLAB. Convolution of 1111, comma 2, 1, 0.5, 0.125, and 25, 0.125. So the result is 2, 3, 3.5, 3.75, 1.785. Okay, so we get the result. So this is the result of the system, and we are able to get the proper result. So with this, the third part of our experiment 1 is over. Thank you.